Have you ever wondered how ChatGPT, Claude, Gemini, and all the other AI assistants are so helpful? Well, if you start working with a base model, that wouldn't be the case. No amount of prompting will make the model be more helpful, to adhere to a specific tone, to be safe, etc. So what you need is post-training. So if you have been wondering, how do you post-train your base models? This is the video for you. My name is Viviana Marquez. I'm a developer relations engineer at Prolific. And today I'm going to walk you through this repo. So the name of the repo is Human in the Loop Post-Training with Prolific. I'll put the link in the video description. That way you can go check it out and build on top of it. So my goal for this video and for this repo is to train a base model. Specifically, I'm going to be training the Quang 3 8 billion base model to speak like a pirate, but not only like a pirate, I want it to be a helpful pirate. I'm gonna be specifically doing this through two techniques. One is supervised fine-tuning and the other one is direct preference optimization. So here in the repo, I have a bunch of notebooks. I'm gonna be walking you through the notebooks. Of course, in production, you will create scripts. That way you can automate the different pieces of the code, but for the purposes of this video, I'll keep it educational, so I'll walk you through the notebooks. But before we get started, let's talk about terminology, so we are all on the same page. This is the overview of the LLM training pipeline. You have pre-training, mid-training, and what is known as post-training, which are actually different several steps. Let's do a little bit more of a deep dive. During pre-training, the model learns about the world via all the code that exists, all the textbooks that exist, all the YouTube comments, basically all text that has been produced by humans is going into there. This is the most expensive part of the training. You need a lot of computing power, you need a lot of time as well, and you need a lot of resources, a lot of data. Once the model has seen all of this data, basically you'll end up with a model that is very, very good at predicting the next token. So for example, if you have a sentence like, the cat sat on the, is going to make a prediction of what is the most probable next token. So in this case, something like, the cat sat on the mat, or maybe the cat sat on the roof. That's pretty cool and all. But if you wanted to do something a little bit more sophisticated, such as, imagine this input, it says, redact all the PII from the support ticket, and then in quotes, you have the support ticket with some PII data like the name, the date of birth, the account number. What this model would do, instead of masking the private information, is that it would try to predict what would come next after that sentence. So for example, it will reply something like, redact all PII from the support ticket, and then the support ticket, and then it tries to continue what the support ticket would look like. So it says something like, I was charged $49 on my visa ending blah, blah, blah. So it starts hallucinating in a way that it makes sense. This is still quite an engineering feat to get a model to talk like a human that has learned the grammar and the structure of language, but it's not helpful. So how do we make it more helpful? There's another step called mid-training. Not everyone does mid-training. This is an optional step, but research has shown that if you continue the training phase, but this time around on higher quality and domain-specific data, it's going to sharpen the model's capabilities before we go on to the post-training. What does this mean? So if you have your raw data, then you train on a very specific subset that has been curated. And then the model, let's say it was trained on a very specific subset of medical data. And you ask it a question like, in summary, the primary diagnosis for this patient was, and the model before mid-training would say something like a serious condition that required treatment. After mid-training, it would say acute myocardial infarction, and so on and so on. So it doesn't mean that the model is capable of following instructions now. It's still predicting the next token, but in a way, it just sounds more legit because it's trained in higher quality data. But that's still not good enough. We want it to follow instructions so they're helpful to us. And that's where post-training comes in. The first stage of post-training is supervised fine-tuning. So supervised fine-tuning teaches the model to follow instructions. How does it do that? Through examples. So what you would give to the model is an input, and you will give it an output, the example response. So you give it well-formatted responses. That way the model learns what it needs to be responding. This is what I'm going to show you in the repo on how to collect that data via Prolific. The next step is preference optimization. So once the model knows how to follow instructions, that's still not enough, because you want your model to be aligned with human preferences for helpfulness, tone, honesty, and safety. So for example, going back to the support ticket, you could have these two outputs, which both are correct. You have the preferred output, which says, I identified 3 PII fields and redacted each one with a typed label. Meanwhile, you could have another response. This response is not incorrect. It says, here you go. My name is XXXX. DOB is XXXX and account is XXX. It still completed the task. It still followed instructions. But of course, between the two, a human might find the first one more helpful because it tells you exactly how many fields did it change. And then for each one of the blank spaces, instead of just writing something generic as XXX, it tells you exactly the type of label. In order to be able to achieve this, what you do is that you give to the model a set of preference data. So you show the model A, you show the model B, and you tell it which one do humans prefer. In this stage, in the repo, we're going to use DPO, but there are different techniques. You have PPO via reinforcement learning human feedback. You also have GRPO, IPO, and all the different variants. The next step is reinforcement learning via verifiable rewards. Training the model on how to go about answers that can be automatically verified, such as math questions, coding questions, and it does this through reinforcement learning. And the last step, but not the least one, actually the most important one, is the evaluation. You can't improve what you can't measure. Also, you don't want to put in front of millions of users a model that has not been validated for its accuracy, reasoning quality, safety, robustness, and alignment. So how do you do that? One is LLM as a judge. You just give the output of your model to another model and you have it evaluate. This is good for scaling, but then you also need human evaluations. This is to detect different biases across demographics, language, and cultures. Also to have domain experts validate the results and validate edge cases, and also for subjective quality judgments such as tone, helpfulness, and cultural sensitivity. Another way to evaluate models is through benchmarks. So benchmarks are standardized tests for capability. We have our own, it's called Humane. I'm gonna leave the link as well in the video description. In here you have the blog, the data set, and the paper. I would encourage you to check it out. And there's many other benchmarks as well. And you should also have a step of red teaming. So you need to do adversarial attacks, jailbreaks, and prompt injection testing to make sure that the model is safe. Are all these evaluations going to be perfect? Probably not. There's probably something that you're going to miss. But the important thing is that you try your best and you do as much as you can. That way it's as safe as possible before you put it in front of people. And that's the LLM training pipeline. So now that we have the terminology down, let's go into the repo. Quick recap of what we're going to be doing. We have a model, a base model that has been pre-trained already. In this case, it's going to be the Quan 3 8 billion base. And then we're going to post-train it. Specifically, we're going to be running supervised fine-tuning to get it to speak like a pirate. And then we're going to do preference optimization via DPO to get it to speak not only like a pirate, but like a helpful pirate. Of course, this is a fun example for this video, but you can apply exactly the same workflow for more serious cases, such as customer support, medical domain, legal domain, even brand voice. So completely up to you on how you design your own experiments. So let's go on to the notebooks. For the first notebook, the first stage is going to be supervised fine-tuning. So I need to give human taskers a question, and I'm gonna ask them, please respond this like a pirate, so I can give those examples to the model. I figured it would be easier for humans to look at an example of how a response should look like, and then translate it into pirate, but feel free to design the task however you want. Prolific in that sense is quite flexible, so you have the choice on how to design the task. So that's what I'm doing in the first notebook. I'm just running all this code, and the result was this file. So let's go check this file. It's just a JSON file that it has prompt ID, the prompt, so how do I make coffee, and some response. That is not going to be perfect because I'm working with the base model, but hopefully this is going to make the task a little bit easier for our participants. So now let's go into the second notebook. In the second notebook, we have all the infrastructure to be able to get those pirate responses via the Prolific API. So one thing I forgot to mention is that here in the repo, I have all the configuration. You do need to create a .env file to add your tokens. So you're going to need a Hugging Face token for when we do the supervised fine-tuning. Same thing with a Tinker token. You need a Prolific API token, so let me show you where to get that Prolific API token. After you have signed up on Prolific, this is what you should see. So we're gonna go to the left, click on API tokens, and here you're gonna see all the tokens that you have. If your account is new, then click on Create API token. You're gonna give it a name, so you could say something like post-training, create token. And here I have this token. So you copy it and then you add it to the .env file. The other two Prolific parameters that you need is the workspace ID. So this is only if you're working in a big organization and you have different workspaces. In my case, I have 3 in my account. I have the Prolific team, my workspace, and the temporary one. Maybe you want a specific one. And the way that you find it is here just as at the beginning when you click on the workspace. So I'm going to switch onto my personal workspace. Here's that ID that I need. So put it in here. The next one is the Prolific project ID. That's if you are organized like me and you like to have all your different experiments in different folders. You have the projects over here to the left. You find your project, so in my case is going to be this one, and you click on it and then you retrieve that project ID that way here and you put it in here. You can also retrieve all the workspace IDs and all the project IDs via the API, but I figured this would be faster. So once you have that, you are ready to go with this one. For this second notebook, we also need a config file. So let me open this config file. We'll get to it in a little bit. And I'm gonna run it from scratch. I already run it for this experiment as the one that you would see on GitHub, but I do want to show you how it would look like from the Prolific side. So here I'm just loading all the usual libraries. Here I'm getting the tokens that I just told you about, and I'm authenticating as myself. Yes, that's me. And here I'm using this configuration file that I just showed you. This is basically what we're going to be sending to Prolific, and this is what the taskers are going to see on their end, so they know what they need to be doing. In this specific case, I called it Pirate Style Rewriting Batch, and I'm asking the participants to answer these questions in Pirate style. I'm going to give them some introduction to the task. What are the steps? And what is the question? This is very important that you take time designing these instructions, because the better you design these instructions, the better the taskers are going to follow them and give you the data that you need. Then you decide how many taskers do you want. In this case, I'm saying I want 10. I'll show you about the placeholder text in a little bit. And for the study setup, you're going to say, how long do you think this task is going to take them? So I say 20 minutes, maximum time 40 minutes, and how much do you want to pay them? So in this case, since it's a task that is going to take them 20 minutes, not 5 minutes, 20 minutes, I'm going to pay them $5 per those 20 minutes. So you decide how much you want to pay them. And here I decide how many participants do I want per task. In this case, I only want 1 participant per each task, because I don't want a rewrite of the pirate style more than once. I only need it once per prompt. The eligibility, the age, basically pretty much everyone in the pool. And for the country of residence, in this case, I thought it would make sense, since we're writing in English pirate, to select people that live in the US and the UK. And of course, you can add as many countries as you want. And the first language, I wanted to be English, because I figured I would get better quality responses, since it's kind of like a difficult task. If you try to get me to speak like a pirate, I would not be able to do that. So that's what I'm doing here in this configuration. I'm reading that file. And then I'm loading the responses that were generated by notebook 1 and setting it up in a nice format that Prolific can accept. So here I have the prompt and I have the response, which is the response that I'm going to give to the participants to use kind of like a reference. And I'm going to save here this file that Prolific is going to take. It's only 100 rows. Notice that I had said that I wanted 10 tasks per participant. So each participant is going to write 10 responses. Here, I'm going to use Prolific's AI Task Builder. So Prolific's AI Task Builder is a human data collection workflow for AI training and evaluation. And it makes it super easy to design tasks, recruit the participants that you need, and gather that structured labels or preferences for pipelines like SFT and DPO, which is what we're currently doing. So the first thing that you need to do is to create that data set on Prolific. So here we see that the dataset was created. Then this next step is just making sure that the dataset is ready to be processed. So here we might need to wait for a little bit, depending on how much data that you have. So in this case, it was quite fast because it's only 100 rows. And here we're defining the task schema. And I'm going to create the batch. So here we're able to see how this would look like from the UI. So if you were creating this task via the UI, this is how it would look like. You will have the ID of the question, the prompt, the example response. I still don't have instructions. So let me create those instructions on the next cell. And this is coming from that YAML file that I showed you earlier. So now the instructions have been added. So I'm going to refresh here. And I should see the instructions. So now I see it here. So write your own pirate style answer to this question. Here I put this placeholder. So this is the placeholder I had here in the YAML file. So yeah, this is just a placeholder. And you can preview it as a participant. So what the taskers are going to be seeing on their end, first is the details of the task. So this is everything that I wrote here in this YAML file. So I'm just giving them the instructions that they're going to see an AI generated response. And we want the response to be like an authentic pirate style. So I'm going to click on next. And this is exactly what the participants would see. So here they would start writing our friendship, mate, something. I'm not going to try to speak like a pirate. So yeah, they would see all the different tasks. So that's what happened there. Now I need to create the batch. After I run this piece of code, I'm no longer able to edit this part here via the UI, but that's fine. So now this batch has been created. The next step is to create a study that references that AI tasker batch. So that's what's happening in here. And basically in this part, I'm using this second part of the YAML file, which is the study configuration. So that's where I decided how many people do I want to work with, how much am I going to pay them, how many tasks I'm going to give them. So here we run this code. And now we can visualize that study via the UI. You don't have to click on the UI steps. I'm only doing this so you know what's happening. But basically, all of these got automatically populated because this is what I had on the YAML file, and I sent that request via the API. Here I'm referencing the batch I just created for the AI task builder. How many participants do I want? I had set 10. And I chose the screeners already. So I already chose that I want people that are between these ages. Then you have the country of residence and people whose first language is English. And Prolific has 165,000 people that qualify that criteria and have been active in the past 90 days. And then here is where you decide how much you want to pay them. I estimate that this task is going to take 20 minutes to complete because each person is going to be writing pirate responses for 10 prompts. So I assume, okay, 10 prompts is going to be 2 minutes per question. So it's probably going to be 20 minutes. And I decided I want to pay them £5. My account is in pounds. And here you see the calculator. So this comes out to be like £15 per hour, which is a good price for this specific task. Of course, if you were working with domain experts, you will need to compensate them more. So the next thing that we need to do is to publish it. I'm not going to do it via the UI. I'm going to do it via the API. So now if I refresh this, I should see it as published. The publish button is now grayed out because it was launched already. So what does that mean? That means that this study now lives on Prolific, is active, and is waiting for responses to start coming in. I had previously run this, so I'm going to extract the demographical data of the participants in case that's relevant to you. For this specific case that I'm training a model to speak like a pirate, not really, but you have it there if you need it. And the participants took on average 22 minutes to answer the question. And it took, to be able to get the 10 participants with 100 responses, keep in mind that there was someone working for 44 minutes. In total, it took 1 hour and 4 minutes. So the participants start coming into your task quite fast. The length of how long are you going to be waiting for the data depends more on the type of task that you have than the participants coming in. The participants are coming in very fast via Prolific. And then we can look at the responses. This is what we care about. So this is all the data you're going to get. So this is the prompt I gave them, the example response I gave them, and this is their response in Pirate. So now we can work with this data to do supervised fine-tuning. So I saved it as a JSON-L file. Let's look at that JSON-L file. So here I have the role is the user. The content is how do I build a good morning routine? So that was the prompt. And here I have the role is assistant and the content is the response I collected via Prolific. Then we are going to go onto the third notebook. So now we are going to do supervised fine-tuning. So for the third notebook, I have this config file. So just what hyperparameters I'm going to use for this model. The most important thing here, I would say, is the LoRa rank. So this is the size of the LoRa adapter. A higher rank means that it's more trainable. A lower rank is cheaper and more constrained. So for this specific task that is very small, we're working with a small model. We are not trying to teach the model a massive new domain. We're only trying to teach it to speak like a pirate. We want to nudge it toward a very specific response style. 16 seems reasonable. So the notebook is mainly reading the config file, setting up the structure to do the supervised fine-tuning. It's also reading the Tinker API because we're using Tinker for the fine-tuning. And we launch the supervised fine-tuning task. This took a while, but I already run it. So here we can look at the metrics at each step of the training process. The most important one I would say is this one. This one is the mean negative log likelihood on the training tokens. We want this number to be as low as possible. Lower means that the model is less surprised by the human reading target responses. So in this case, by the pirate responses. So we would want to see this number decrease at the end of the supervised fine-tune task, which was the case. We saw it going from let me see up here. It was going from 2.82 to all the way down to 0.6. And now we can see the results. So here in the output, you have everything that you need to be able to access this model again, because this model is being trained in the cloud using Tinker. And now we can take a look at notebook number 4. So now notebook number 4 is basically a sanity check. We want to compare the base model against the supervised fine-tuned model to make sure that it actually learned. So here we're just loading the model back from Tinker. And here I have some test prompts to test the two models against those prompts. And here we see the results, and we can quickly see that the model was successful in learning how to speak like a pirate. So the SFT model, definitely sounding like a pirate. But I had said that that's not enough. We want the pirate to not only speak like a pirate, but be a helpful pirate. So we do that via DPO. So in this notebook, we're going to generate the preferences to be able to run DPO. So basically what's happening is that we're using the model that we just trained to generate two kinds of responses. And that way the participants can pick which one is their favorite response. So I can just show you the output. So let's go here. And this is how the output looks like. So you have a prompt. How do I start a conversation with someone I don't know? That's one of the prompts. And you have response A and response B. So we are going to tell participants, hey, pick the one that is the most helpful one. So that's what we're going to do here on notebook number 6. Let me show you the configuration file. Very similar to the previous one, because we're also going to be using Prolific's AI Task Builder, but in this case, instead of asking participants to write like a pirate, we're going to ask them to click between one or the other. Which response do they prefer? It's the same thing here. You need to give them very clear instructions. I avoid telling them something like, which one of the two responses do you prefer? Because people have different preferences. I tell them exactly what I need. So for example, in this case, I want it to be a helpful pirate. So I tell them, please select the response that is the most helpful one. The one that is more detailed, that has more practical advice, and so on. This part is very important because if you don't give good instructions to your taskers, they're not going to give you the data that you need. So this stage is critical. All right, so let's go on to the notebook. Very, very similar like the previous one. Let me rerun this part to show you step by step what's happening on Prolific. So here I'm just loading the credentials, the YAML file, very similar to the previous one. The only difference is that now they're going to see prompt, response A, response B, and their task is going to be to select one of those two. And I'm using the AI Task Builder. So exactly the same process as before. We're creating our data set. Here we wait for the data set to be ready. So I fast forwarded. That way we wouldn't be waiting for a few seconds in the video, but it wasn't that long. And here is exactly the same thing. I'm just defining the task. So let's see it on the Prolific side. And let's add the task instructions. That way we can preview it as a participant. And there you go. So now you see that it's slightly different. Instead of having a box where they can answer free text, they just see these multiple choice questions. And let's preview it as a participant. So again, you have the task with the instructions. And here, instead of the box, like I was just mentioning, you select which one do you think is more helpful. So this is what the participants will be seeing on their end. All right, cool. So now let's launch it. Same thing as last time. You're going to create a study. So now let's click on it. And you can see all the things I specified in my YAML file. Same as before, we see the number of participants that are eligible for this task and how much we are going to compensate them. So in this case, I'm going to compensate them a little bit less because I expect them to take 10 minutes to do this task. They're not going to be writing, they're just going to be selecting which one do they prefer. And now I'm going to publish this study on Prolific. And here we can start seeing people coming through our study by the minute. So it's very fast. So now let me show you what does it look like after you get all the preferences. So again, you can get the demographic data, and you can see how long did it take participants to complete this. So on average, it took them 11 minutes to complete this task. It took 2 hours and 22 minutes to find 250 participants to give preference on these 1,000 responses. By the way I designed this is that each task, each preference pair is evaluated by 5 participants. That way I can get a sense of what do people prefer, not just the vote of one person. And we can see the responses here. So this is how it looks like. You have your prompt, the response A, response B, and then you can see the votes basically. So for example, in this case, response B was more popular. All the annotators agreed that response B was more helpful. So this is a very strong signal. You have some other ones that are a little bit more mixed, but the idea stands. I also wanted to look at the distribution of annotator agreement. And this is basically what I was expecting. Most people agree completely on which one is the best one. Some other ones, the signal is not so strong. And then this one is a little bit of a weaker signal because it's almost half and half. So to make the model super clear on what do we prefer and what do we not prefer, I'm only going to use the 4-1 and 5-0. So let's look at this output file. And let's open one at random. So we see that the preferred response was B. And here we can see the prompt, completion for A and completion for B. So we're going to give this data to the model that already went through supervised fine-tuning to now go through DPO. So that's what's going to happen in the next notebook. So in this next notebook, we are using Tinker again for DPO. And basically, this is just the configuration. Let me open the configuration file so you see it. Very similar. Once we start going through this notebook, we'll see the results. So this also took a little while to train, but we can see the results. So on each run, we get the metrics over here. And the most important one to look at is the DPO loss. So this is the DPO classification style loss. We want this number also to go down. So let's look at the final result. We had 0.65, and then let's go at the final one. And we have for the DPO loss 0.000115. So this is very, very low. It means that the model is not struggling at all to distinguish between the chosen and the rejected responses in the batch. We have accuracy 100%, which is a little bit concerning. Maybe we have a little bit of overfitting here. But let's look at the results and go from there. So that's what we're going to do on the notebook number 8. We have the results. So we're going to compare the base model, the supervised fine-tune model, and the DPO model. And it's the same code as the previous notebook where we were comparing the 2 of them. Instead, in this case, we're going to compare the 3 of them, and I'm loading the 2 models from Tinker. And here we see the results. So for example, how do I apologize properly? The base model that has gone through no training, sometimes it gets it right, sometimes it doesn't get it right. In this case, it didn't get it right. So it says, okay, the user wants to know how to apologize properly. Let me start by breaking down the key elements of sincere apology and so on, which is not very helpful. If you ask this, you wouldn't want this to be the answer. So the supervised fine-tune model replies like a pirate, but then the DPO model responds like a pirate that is more helpful. It gives a longer answer and that is more detailed. So our small experiment worked. Of course, like I mentioned in the beginning, this is a fun experiment to get a coin model to speak like a pirate, a helpful pirate, but you can use exactly the same workflow to more serious use cases, customer support, legal domain adaptation, some other type of domain expertise adaptation, or even brand voice. So I'm curious, what are you going to build now that you know how to post-train a base model? Let me know if you have any questions in the chat section, and I'll see you in the next video. Bye bye.